So here we have the property of sides in quadrilaterals. Quadrilaterals themselves, not special, they just have four sides. A trapezoid has at least one pair of parallel sides, so an isosceles trapezoid has that same feature, and its legs are congruent. Parallelogram has the opposite sides parallel and congruent, just like a rectangle. And a rhombus has all the sides congruent with the opposite sides parallel, just like a square. In looking at the angles, quadrilateral, again, nothing special. Trapezoid, the same side interior angles are supplementary. In an isosceles trapezoid, the base angles are congruent. On a parallelogram and a rhombus, the opposite angles are congruent. And in a rectangle and a square, all the angles are 90 degrees. And in terms of diagonals, for a quadrilateral and a trapezoid, nothing special. They both have two diagonals. Isosceles trapezoid actually has congruent diagonals. For a parallelogram, they bisect each other. They're bisectors. For a rhombus, they're bisectors, but they're also perpendicular, meaning they make 90-degree angles. For a rectangle, they're congruent, just like this, but they're also bisectors. And for a square, they got it all. They're perpendicular, 90-degree angles. They're congruent, so they're the same length, and they bisect each other. So for this example here, we get that the measure of angle BAC is 3x plus 4, and the measure of angle ACD is x plus 28. They want to know what is the measure of angle CAD. This is a big multi-step problem, but the first thing you should look at is what's the relationship between these two angles. And it's a rectangle, so I know that these lines here are parallel to each other, and the angles I have labeled are alternate interior angles, which means they're congruent. So if these angles are congruent, what you can do is you can take them, 3x plus 4 and x plus 28, and set them equal to each other, because these angles are going to be equal. And then let's solve it for x, because that's going to give us a little more information here. So subtract x on both sides. We get 2x plus 4 equals 28. Subtract 4. That cancels. We get 2x equals 24. Divide by 2. And we get x equals 12. Great. Cool. So what we're looking for, though, we're looking for angle CAD. So we want to know, what is this angle right here? That's our big question mark. So first, let's figure out what this angle is. Let's plug back in this x plus 12. So we got 3 times 12 instead of x plus 4. So that's 36 plus 4. That angle here is 40 degrees. Okay, so let's find this red angle that we're trying to look for. One thing I know for sure in a rectangle is that these angles have to add up to 90 degrees because it's a rectangle and the corner is 90 degrees. So what you can do to get that red angle is just do 90 minus 40. So 90 degrees minus 40 degrees, that leaves us with 50 degrees for this angle, because it has to make a total of 90, and we already had the 40 from what we solved before.